Okay, this is the 6.5 and 7.7 review. Number 3, calculators are not allowed. So each of these three asks for the average value of the function. So we need to be able to set up the 1 over b minus a times the integral from a to b of the function that we want the average of. So we'll do that with each of them. Now, because we don't have a calculator, we need to compute this and simplify it by hand. So on this one, I'd get a 1 over 8. And then I'll ask myself, what did I take the derivative of with respect to x that gave me the sine of x? And the answer to that is a negative cosine of x, evaluated from -2 to 6. So the first thing I will plug in is the 6, and then I'll subtract what comes out when I plug in the -2. Now notice that subtracting a negative is the same as adding, and we could rewrite this as a cosine of -2 minus a cosine of 6 over 8. Now looking at this, I see that there is a nice simplification that I could use that utilizes the even properties of cosine. I know that with even functions, if I plug in a negative, I'm going to get the exact same thing out as when I plugged in the positive. I also know with odds that if I plug in a negative, I'm going to change the sign of the positive. So there's a good chance that that will come into play on the exam. So I would need to fix this and make it a cosine of 2 minus a cosine of 6 over 8. If we look at part B, we're involving exponentials. So we need to be able to work with exponentials. So I'd have a 1 over a b minus an a times the integral from -a to b of e to the x with respect to x. Answer the question. What did I take the derivative of with respect to x that gave me e to the x? Well, that's just e to the x. And then I need to evaluate from 1 to -1. So I'll have a 1/2 e to the 1 minus e to the -1. Now if this were on the test, I would not leave it like that. I would make you work a little harder. So I would have you simplify this, get a common denominator, and then distribute the 2 through. Okay, the final one, part 3, is a polynomial. So again, I'll have 1 over b minus a integral from a to b of the polynomial. And I need to make sure that I answer the question, what did I take the derivative of with respect to x that gave me that inside? And that will be an x cubed plus an x squared plus a 4x evaluated from 0 to 2. I plug in the 2 first, and then I plug in the 0. I'll get a 20 divided by 2 gives me a 10.